Okay, cool. Good afternoon, everyone. Welcome to your first 10th CBSE class. Now, as we know that 10th is a board class and apparently that is why it is important. But I just want to mention two things. Yes, 10th is a board class and it is kind of important, but according to me, board exams are not that difficult. Second point that I want to mention is that there is a more important point why class 10th is important. Why? Because the conceptual training starts in class 10th. Now, obviously, conceptual training is very important because conceptual clarity gives you clarity of basics. And if you have conceptual clarity and you have the knowledge of the basics, you can solve any question you come across after your 12th or in your 12th. Right? So, that is why class 10th is very important. Because your conceptual training starts here. That is why we'll be focusing more on the conceptual basis. Right? So, we'll be starting with the very first chapter of class 10th, which is real numbers. And without further ado, let's start. Right? So, since I just said that we'll be focusing on the conceptual training, we'll go back to the basics. That means we'll go back to class first. Right? Just try to remember what you learned on the very first day of the school. The very first day. Probably you will say the counting numbers, or now we have a better word for it, that is natural numbers. Right? Obviously natural numbers as in 1, 2, 3, so on. Now the question is, if I want to study about a particular natural number, let me take an example. Suppose 72. It is a natural number. And I want to study all that there is about this number 72. Right? Now, there are two ways of analysis. If I have an object, what I can do is I can study the object in its entirety, right? Or I can study the parts of it. Now, my study is with regards to the number 72, right? So, either I can study number 72 as a whole, or maybe if I want to analyze it, I can study its parts. Now, the question is, what do I mean when I say that I am talking about parts of this natural numbers? Parts of a natural number. Now, let's use a very important thing which you should definitely have, and that is called common sense, of course. Now, use it and tell me, when I say, let's talk about the parts of 72, what will you think about? Just think, what is 72 made of? 72 is made of, oh, I can see a 2-factor. I can see another 2-factor. Basically, I can see 3 as well. Or when I say what is 72 built of, maybe I can just write the prime factorization. Right? Now I know that 72 is nothing but 8 into 9. So the prime factorization is 2 cubed into 3 squared. Right? 72 is definitely made of the prime factor 2 and the prime factor 3 and their respective parts. Now, I wanted to study this number, as in I wanted to establish the properties of this number. Instead of that, I will establish the properties of these prime factors. Because whatever the property of 2 might be, whatever the property of 3 might be, that property will be present in the number 72. So, instead of studying the number as a whole, I will be studying its parts. Now, instead of using the word parts, I will say building blocks. Right? Instead of studying the entire building, I will just study its building blocks. So, you can say that prime factors, or prime numbers I should say, prime numbers, are the building blocks of a natural number. Right? Any natural number you take, you can write the prime factorization. That means you can talk about the parts of it. Right? So this is a very important thing, that the prime numbers are the building blocks of a natural number. This will help us a lot in the future. And this is very commonsensical also, so you don't need to learn it. You already knew that. I'm just trying to get out what you already know. Right? Okay, now here I have used the word prime number. I know you already know the definition of it, but I will just recapitulate it once more. A prime number is a natural number greater than 1 which have exactly 2 factors, exactly 2, 1 and the number itself. Right? Okay. Now, the next question might be, since we are talking about prime numbers, how do we ascertain whether a number is prime or not? In fact, let me ask you this question. Let's take the number 83. Right? Establish whether it is prime or not. I know you know the answer. I know that. But you need to justify it. If it is prime, you need to justify it that it is a prime number. Justification is very important. I think sufficient time. You should be able to justify in this much amount of time. It's absolutely fine. So now we'll focus on the board. Yes, we will focus on the board. Yes. Now I want to see whether this number is prime or not. That means I need to check whether it has exactly 2 factors or not. Right? So factors obviously would be numbers less than this. So let me talk about the numbers less than this. So let me write 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, आगे वाले नहीं लिखे मैं, my way. Right, now let's talk about 1. Do you think 1 is a factor of 83? Yes, of course. So एक factor तो मिल गया. Do you think 2 is a factor of 83? Of course not. This is not an even number. So इसका factor 2 तो नहीं होगा. Now, अब तुम 3 पे जाने की बजाय first of all think about it. If 2 is not the factor, do you think 4 will be the factor? 4 में भी तो 2 है, right? Obviously 4 will not be the factor. अच्छा, what about 6? It will not be the factor. 8? No. 10? No. In fact, any even number would not be a factor of 83 because common sense. Right? Let's move on to this one, 3. Now, do you think 83 is divisible by 3? Absolutely not, because sum of digits is not divisible by 3. That means the number is not divisible by 3. Right? Now, if the number is not divisible by 3, do you think it would be divisible by 9? Of course not. Okay, so 9 is gone. That's a 5. We know the divisibility test of 5. So, no, 5 is not the factor. 7 is not the factor. And so on nahi bola maine. Now, a very important point. I have stopped writing the numbers after 10. Now, the question is that a coincidence or I was being lazy? Or maybe there's a material motive. Why did I stop at number 10? Think about it. Why did I stop at number 10 specifically? Okay, I think that's sufficient time. Now, before we come to that, let me just take you to the right hand side. So, on this side, because I want to establish one thing. Suppose I have the number 84, right? I can very well write the factors of 84, right? I know that 1 is the factor. Now, if 1 is the factor, the corresponding factor should be 84, right? Cool. And 2 is the factor, so 2 and corresponding factor would be 42. Then 3, that is 28. Then 4 is there, so that is 21. Then 6 is there, so that is 14. Then 7 is there, and corresponding factor is 12. Now, you can say that 12 is the factor and the corresponding factor is 7. But I have written all the corresponding factors as it is. Now, when you look at this, what can you establish? 184, 242, 328, 421, 614, 712. All the factors, it seems like they occur in pairs. Make sense? Right? There would be a factor, and if that is the factor, that means corresponding factor bhi hoga. So all the factors occur in pairs. Okay, make note of that. Let's see. Now, I know that 83 is not divisible by 10. I know that. But if it, now we can't even imagine, but let's just try to imagine. So 10 into the corresponding factor, if it would have existed, it would be like 8 point something. In fact, 8.3 to be more exact, but you get my point, right? 8 point something. Now, notice if 10 is the factor, the corresponding factor is less than 10. Now, if I increase the number, suppose 11, right? The corresponding number would be 7 point something, right? Again, the corresponding factor is less than this one. Now, if you notice, I have established that all the numbers less than 10, they are definitely not the factors. Now, if these are not the factors, you will not get the corresponding factors. Right? अब यही नहीं है तो इनके corresponding factors कैसे होंगे? Right? So that is why there is no need to check whether the further numbers would be factors of 83 or not. That is why we stopped at 10. Right? Now, since we were unable to find any other factor except for 1 and the number itself, obviously, that is why 83 is a prime number. Right? Why I took this example? Because I want to establish one method. Now, how we establish whether the number is prime or not? I considered each and every number, up to a certain number, yes. Each and every number, and I checked whether that number is a factor of that or not. Basically, I filtered out, right? Or instead of filtering out, maybe I can use a better word, and that is called sieving out. Right? I'm sure you know the meaning of sieve. If you bake, you would know that. So this method is actually known as the sieve method. And this was given by a Greek mathematician whose pronunciation I'll definitely screw up. But let's just try. First of all, I'll write the spelling. Don't take me on the spellings also, it might be wrong. But yeah, it is. Where is it? Maybe I should just look at the spellings itself. So, this is, I pronounce this as Eratosthenes. This was a Greek mathematician and he gave this method, sieve method, in order to establish whether the number is prime or not. Now this is a very commonsensical method. If you would have been born in that era, maybe it would have been sieve method by your name. You were born a little late. Right? Now let's take another example. I will not give much time to it, but yeah. Now establish whether 757 is a prime number or not. Check whether 757 is a prime number or not. I will not give you much time to establish. Use this method in fact because it is, it's quite an old method and you should know the basics. Hurry up. Nobody will use the calculator. I know that you can do that, but no Google, no, don't use Google. Don't establish whether this is a prime or not. Alright, I think sufficient time. So again, if I want to check whether 757 is a prime or not, what I'll do is I will check whether it has more than 2 factors. Right? So I will write the numbers 1, 2, 3, 4, 5, 6, 7, so on. Now the question is still there. Should I write 25? Yes. Because if 25 is there, the corresponding factor is definitely greater than 25. Okay. 26, the corresponding factor is still greater than 26. So yeah. 27, yes. Because 27 corresponding factor would be 28 point something, right? 28. Now when you come to 28, the corresponding factor you can see it would be less than 28. Right? Because 28 into 28 कितना होता है? 28 square is 784. Right? मुझे 757 चाहिए. That means this number would be less than 28. Maybe it is 27 point something. I don't know. Maybe it is 26. I don't know. Right? So now we found out if 28 would have been the factor, the corresponding factor would be less than it. And all the factors which would have been less than it, I've already checked. Right? You have already checked, not me. It's your job. Do it yourself. Right? So all you need to do is check whether all of these numbers are factors of 757 or not. One is obviously 1. It is the factor and corresponding 757. And you will realize that all of these numbers do not divide 757. That means yes, 757 is again a prime number. Right? Before we move forward, I just want to point out one thing which is very interesting. Look at the prime number. 757. Okay. Look at the prime number again. 757. That means the prime number reads same front and backwards. Right? When that happens, the number is called palindromic. These are interesting things to know. Right? And since it is a prime, we call it palindromic prime. Not a rocket science. Right? Now, there are various palindromic primes. You can say 101 is palindromic prime. 10301 is palindromic prime. Oh, 11 is a palindromic prime. right? They are palindromic words, palindromic sentences, palindromic poem even. So you should definitely check it out. Those things you can Google. That's right. Cool? Right. Okay. Now, moving forward. We have talked about prime numbers, right? Now, suppose the number is not prime, what do we call it? Yes, we call it not prime, but there is a separate word as well. The word starts with C. We call it composite number, right? So, any natural number is either prime or it is composite. Any natural number is either prime or composite. Is the statement correct? Are we forgetting any natural number? Let's see. Prime ho gaya, composite. You forgot one natural number. That is 1. Now, 1 is nice because it is neither prime nor composite. Right? So, natural numbers are divided into 3 categories: prime, composite, or the number 1. Right? So, the thing I said, a natural number is either prime or composite, I should rectify it. A natural number greater than 1 is either prime or composite. Alright? Also, we have checked how to ascertain whether the number is prime or not, right? The sieve method. Now, how do I check whether the number is composite or not? Check whether it is prime or not. If it is not prime, it is composite. Right? So, you know how to check whether the number is prime or composite. You know all of that. Right? Moving on. Then let's do a tiny question. Prove, write down, prove the number 2 into 7 into 11 into 13 plus 161 is composite. Prove this number. This is the entire number, people. This plus this. That is the number. Prove that it is composite. Right? I will not give you time. You can pause the video and you can do it and then unpause it and move on. Right? So I will discuss it. So I'm discussing it. So pay attention now. Right? I need to prove that this number is composite. That means it is not prime. That means it must have factors other than 1 and the number itself. It has more than 2 factors. More than 2 factors and some factors exist. Let's study the number. It is this plus this. Right? Since बीच में plus आ गया, maybe I might be able to take a common factor out. Right? अब यहाँ पे 2 है, 161 में at least 2 तो नहीं है. Right? Okay. 7 है, 161 में 7 present है. Oh, it is divisible by 7. I can write. So 2 into 7 into 11 into 13 as it is. Plus, since I want 7 to be out of here, so 7 into that is 23. Right? I can take 7 common out. So this is 7 into 2 into 11 into 13 plus 23. I hope you know how to take things common out, right? We are in class 10, we already know this. Right? So I have written this number in this way. I have written this number as product of factors, and this factor is neither one, obviously 1 is 7, and it is not the number itself. So I found another factor. That means the number is not prime. Since it is not prime, it is composite. Right? Write down another one. Prove the number 55 raised to power 4 plus 4 is composite. You will not use calculator, you will not use Google, and you will just use your common sense. That's it. That you can use. Prove that the number is composite. Right? I think sufficient time. Let's discuss it on the board now. Right. Now, I need to prove that it is a composite. That means if I'm able to find another factor, except for 1 and the number itself, I'll be able to prove that it is composite. I am looking for another factor. एक factor चाहिए. That means यहाँ पे factorization होनी चाहिए. Right? All I need to do is try to factorize this expression. Right? Now, factorization of expression is done in which class? Let's see, when in class 10, obviously class 9 would have some factorization, right? So, some factorization. कैसी factorization पढ़ी है class 9 में? Let's just try to remember what happened in class 9, right? Factorization 1. A square minus b square, factorization is was there, right? Which was a plus b into a minus b. Then it was a cube minus b cube. Then a cube plus b cube, right? These were the some identities we learnt in class 9 in order to factorize. Now again, this is an expression, right? Term 1 is there, term 2 is there. I am just asking you to factorize the expression. Now first of all, see, यहाँ पे पार even है. क्यूबिंग वाले फॉर्मूले तो नहीं लगाऊंगे, right? Even पार है, स्क्वायर्स में आता है, मैं स्क्वायर्स लिख लेती हूँ सबसे पहले, right? At least मुझे 4 दिख रहा है, that is 2 square. And I need to write 55 raised to 4 as a square of some quantity. Can I do that? I know the law of exponents. So this is nothing but 55 square whole square. Right? I can write this as this. Plus, now 4 is obviously 2 square. Now this is, suppose if I am considering this to be a. So this is a square plus b square. Oh, damn it. Minus some. A square plus b square, we do not know how to factorize it. Okay, it's fine. Now, but a square plus b square, this thing comes up in something. These two terms comes up in what? A plus b whole square. In fact, I can write a square plus b square in terms of a plus b whole square minus 2ab. You know that a plus b whole square is a square plus b square plus 2ab. मैंने बस side change करी है, that's it. You know this, right? Now a square is there, b square is there, d square is there. So let me try to use this identity. ये वाले नहीं लगे, ये वाले दे देते हैं. इसकी factorization identity नहीं है, but some identity is there at least. Let me try to write that. So this is equal to a plus b whole square. Now a is this entire thing. This is a and this is b. So a plus b whole square, a plus b. Minus 2ab, minus 2. A was 55 square into b, which was 2. Now I think the question is done. It is done now. I can easily factorize it. Now this is something because I am able to produce negative sign in between, right? A square minus b square. This factorization I know, right? Because I needed minus sign and somehow minus sign have been generated. A square minus b square. A square. Now this is a square quantity. If this entire thing would have been squared quantity, my problem would have been solved. This entire thing, is it a square quantity? Let me see. 55 square. 2 is there, 2 is there. Yes, this entire thing is a square quantity. Look carefully. This is 2 square into 55 square. Right? Laws of exponents, no. I can write this as 2 into 55 whole square. 2 into 55 whole square. Right? So entire thing, 55 square plus 2 whole square minus. Now this is, now instead of a square नहीं तो पहले वाले से confuse हो जाएंगे, मैं बोल देती हूँ x square minus y square, right? So let me write this x square minus y square. This factorization I already know. I will just apply it here. Now here the x is the entire thing, x plus y. This is x, this is y. So 55 square plus 2 into 55 into x minus y. X is this. 55 square plus 2 minus y is 2 into 55. What I've done is I have written this expression in terms of this as product of two factors. Now, clearly this factor is not 1. Obviously not. Clearly this factor is not the number itself. Number itself is product में लिखा है, right? This is not the number itself. That means I have found another factor. Since it has another factor, definitely it is a composite number. Right? So all you need to do is find another factor. Factorization करनी थी. That means class 9 question was there. Pretty simple. Right? Moving on. Write down another one. Now, I'm hoping that everybody know how to prime factorize the number. So, write the prime factorization. Write the prime factorization of the number. Where is it? 6,468. As fast as you can, please, but without any error. Very important. Hurry up. Sufficient time, I guess. Almost done. 10 seconds left. Right. The prime factorization, I'm hoping that you know, it came out to be 2 square into 3 into 7 square into 11. I'm not going to discuss how prime factorization works because that is a very baby question. Right? I gave you a natural number and I asked you to prime factorize it. If I give you any natural number, can you prime factorize it? The answer is yes. You can factorize any natural number, obviously greater than 1. Right? Now, you said you can write any natural number as product of factors. As product of prime factors. This is what you said. When I say prime factorization, that means you're writing the natural number as product of prime. Right? You just said that? Right. And I should mention greater than 1. Obviously. Greater than 1. Now, listen to my next question very carefully. I will ask you, is this factorization unique? The prime factorization that you did, do you think that is unique? I am hoping you know the meaning of the word unique. Right? Now, let's just try to analyze. My prime factorization was this, right? Now, some of you might have written the prime factorization, right? 3 into 2 square into 11 into 7 square. Right? Now, clearly this and this, they are the same. Right? What if there is another kid who would have written 11 into 7 square into 2 square into 3? This is also one way of writing the prime factorization. It's absolutely fine. Right? This is same as this is same as this. The only difference, that is in ordering. Right? So, if you have written this, indirectly you have written this, and blah blah blah. Right? So, if I ask you, is this prime factorization unique? You will say yes, it will be unique. Let's write it. This factorization is unique, except for the ordering of the prime numbers. Except for the ordering of prime numbers. Right? Now read these two statements. Read it together. Because this will lead to a very important result. That is the first result of class 10 actually. Now, let's read it together. Now, he says, any natural number greater than 1 can be written as product of primes. And this factorization is unique except for the ordering of the prime numbers. So, any natural number, product of primes, done, and the factorization is unique. When we combine these two, this is nothing but fundamental theorem of arithmetic. The very first result of class 10. Right? Arithmetic you started studying in class 1. Now you are studying the fundamental theorem. Right? Which is nothing but the commonsensical part. Right? Now this theorem was actually given by, again, a Greek mathematician, because at that time Greek civilization was doing tremendously. Now, the mathematician was Euclid. I'm sure you already know him. He has written a very famous book called Elements. You must have read that in your geometry classes. Right? So, he worked in geometry, he worked in arithmetic also. In fact, he gave the very fundamental theorem of arithmetic. Right? He gave the theorem, but he did not give the proof of it. Okay, can you guess who gave the proof of this theorem? That was German mathematician named Gauss. Carl Friedrich Gauss. Right? And a very peculiar thing, Euclid was in some 200, 300 BC. I don't know exactly, but in some year of BC, right? 8 years before Christ, obviously. And he gave the theorem. Gauss gave the proof of it in 1801. Look at the time elapsed, BC to 1801. It took this much amount to prove a fundamental theorem. Fundamental theorem को prove करने में इतना time. That means there is something about this theorem. It is not, yes, it seems trivial, it seems commonsensical, but there is something about it because the great mathematicians, they took so much time in order to prove it. The significance of this will be pointed out in later classes. Right? So with this, we'll end the first lecture. With this, the first result of 10th CBSE, we are ending the lecture. And this is a very important theorem. So that's it for today's class. Home assignment will be uploaded, which you already know. And thank you. I will see you next time.